Hi there, this is Robosapien version 1 and this is my 5th video. What I want to do here is to look at the gripper or the claw or the hand or whatever it's called to see if I can improve how that works. In the model as supplied, if we for example had something it wanted to pick up, then to open the gripper it turns what? It turns the elbow. By turning the elbow it opens the gripper, it then comes across, bends from the waist, closes the gripper, opens the gripper, closes the gripper on the object, lifts the object up, and it can move the object around. To drop the object then, it opens the gripper, turns the elbow which opens the gripper, and it drops the object. So that then is how Robosapien sort of works to pick something up. If we want to have a look at the gripper itself and try and put in its own independent motor so I can use it independently of the elbow, then I need to take it apart. I've just stuck it back together again with bits of tape so that hopefully I can get these bits of tape apart quicker than using the screws. There should be 3 screws, 1, 2, 3 up at the top here and 1 there. So that's 4 screws that hold this top bit in, and if I'm careful and I hold the right bits, then that top bit comes off. We can see up at the top incidentally how that is got a bearing, and it's a sort of flange type bearing that is held by the body to stop it from wibble wobbling like that, because all this top part is connected is that rod through the hole. So if we push it back, then that comes away, and we can take this top bit away as well. And what we can see is that the wire that comes from the circuit board, it should have been plugged in there, but I've unplugged that, just goes straight through the top bit and can be disconnected from that and is nothing to do with that top bit. So that's the top bit, and here we have the gripper, the elbow. This is the elbow motor here, and the gripper down at the bottom. And if I twist the elbow, then the gripper opens and closes. If we look inside this, then what we find is what? Will it come apart? This should have 6 screws, 1, 2, 3, 4, 5, 6, which of course I've taken out before, because watching screws being taken out is like watching paint dry. Anyway, so here we have it. So what do we want to do? We want to zoom in on this to see how it's actually working. So let's go down here, move the camera, and let's see what we can do. Can we do anything? Nope. Can we move in? Nope. Let's leave it at that then. Okay, so what have I got? Inside here we've got the motor. Now the motor's interesting in that it's different than the others in as much as it's a sort of angle. The others are in a sort of straight line, more like what? More like this. So this is more of the type of motor that you get on the shoulders, waist and the legs, but this one in the elbow is a sort of right angle thing. It also has 2 outputs on it. So we have this one at the back which has a cam on it, and then we have the mechanism at the front which actually is the bit that sticks out here. So that's the bit there, and if I twist that, hopefully we can see that this cam here also moves, and that's the cam that moves the hand. So if I twist that in the right direction, you can see, hopefully, that shouldn't really be there, should it? Make it easier to see that it opens and it closes. It only opens and closes right at the end, so down here when this cam is moving away, it's not actually going to open, but only when the cam comes up and pushes on this black bit here. If I move it away, I can push on the black bit to show how it works, and that then is pushing down. It works on a slot which has got this rod going through it, and then at the other end it's held onto the circular end of the fingers. The three fingers then just come in and touch onto that blue plastic, and as the blue plastic moves away, it moves the inside of the finger, which then moves the outside of the finger. So quite an interesting mechanism. Incredible is the amount of pressure that's needed to actually push that. So I'm wondering if I can actually make something which will be strong enough to push it. If we go back to our little cylinder, push it down, it'll pick up, hopefully it'll pick the cylinder up, and if I push it down again, it'll drop it. So that's how it actually works. So can I modernize it? Can I mechanize it? Can I put a motor in there so that it will actually work? There's not too much room with this black mechanism. The blue bits here are just there essentially to hold the rod in place, and then we've got a lot of plastic. Down at the bottom it's difficult to see, but I think I have one here that I prepared earlier, is the end of the wire that comes in, and that has some nice little sockets on it into which plug four things. The first one is the motor, second one is the switch which is up at this end, don't know if we can see that or not, which when this turns, if I can turn it which way, this has got a cam on it, and that cam then pushes against the little switch which is fastened on. Here's the little switch fastened on, so that when the cam is in the central position, pushes on the switch and tells the microcontroller, hey, I'm in the central position. And then when it moves away, it just move on time one way and time the other way, and then come back to the center. So that's another one of the controls that are coming away. Also we have two wires for this switch, which is on the end of the arm, and also if we look inside, there's an LED, so we have two wires for that. So this big wire has 8 wires going through it back to the main processor board. I think that's all I need to say about that, so let's have a look at the modification. So how have I modified it? Well, let's try first of all, does it work? Well, what I've got is my trusty servo controller here. Some power, give me the power, yes I need the power. Put the power on and hopefully we can see the motor can open the jaws. It's not working very well at the moment, but the problem with it is, as far as I'm concerned, Oh dear, we've lost it. When the jaws are open, the servo that I put inside, oh dear, how's that got in there? The servo I've put inside, can we see that? I've just put a servo in there with a wire going onto this metal plate, and this metal plate then should push against there and open and close the hand. It's very crude. Oh, the hand's coming out. That's the problem with it. It needs holding it in for it to operate better, I think. And there, hopefully, we can see the hand opening and closing based on the servo. But as I say, the problem is when it's open, if I disconnect the power, the servo is pushed back and therefore the hand closes. So it needs permanent power on it to keep the fingers open. To do this then, I can still get the motor back in if I can find it. What have I done with it? Put it somewhere. Anyway, I can still get the motor back in, but I have had to take out the connector at the bottom, but that doesn't matter because I'm going to be using different wires to go back. Obviously I still have to use the positional switch for the elbow motor, and then I've taken out the LED. I've taken the LED out because my idea is that when this is open, I could have a reflective opto switch there, so that when something's put in, the controller will know and will close the hand, and then it can move it and then open again. So, but this mechanism using the servo isn't what I want, because the hand spring just closes it. So where do I want to go from here? Well, it looks like I probably need to go to a proper motor, well, a non-servo motor with a gearbox, put a thread on the end of that somehow that will push against my lever, and that will open and close the hand. But when it's open, the hand will stay open until the motor goes the opposite way and lets it close. So yeah, that works, but it needs, well, it need looking at if I wanted to make it permanent, but I do need to go to a geared motor, and that's going to need end switches on it as well, which will make it more complicated. So yeah, I've got a success with my servo. I was surprised it would actually operate against this strong spring, which it does, but it isn't what I want. So it's back to the drawing board. It was interesting to do, it works, but got to move on. Bye now, bye.